Good morning, my dear students. Today I am going to start a new topic that is called continuity. From this chapter, in the board examinations, two questions asked. One questions contain 4 marks and another question contain 1 marks. 1 mark, okay? So this chapter is compulsory questions always asked from this chapter, and it is a very important chapter for you. And to know about the continuity, you must know what is limit. Without clear concept of limit, you cannot understand continuity. Okay, before going to enter the topic, I just want to say what is continuous. Continuous means there is no break. So in terms of the language of mathematics, continuous function means without lifting the pen, if you draw the graph throughout its domain, then you can say it is a continuous function. For example, suppose that this is the domain of the function, something, suppose the domain, suppose I, it is the domain of the function. If you draw the graph like that without lifting throughout its domain, then we can say that it is a continuous function. That means a function is continuous means it is continuous in its domain. That means it is continuous at every point in domain. So for this point C, there is no break. For this point C, there is no break. The function is, there is no break in between between the points within the domain. Therefore, we can say the function is continuous function means it is continuous at every point in its domain. Okay, now before going to define what is continuous function in a particular point, what is it, when a function is continuous at a particular point, or when a function is continuous at a general point in its domain. So before going to define this, I am just give an idea about limit, because this particular chapter you already learned in class 11. Okay, so suppose that this is the number line minus infinity to plus infinity, and suppose that this is the set of the real numbers, okay, and a is any real number, okay, and x is approaches to a from right, x is approaches to a from right, and here x is approaches to a from left. X is approaches to a from right means you can say x is greater than a. Whatever be the x approaches to a from right, all x are greater than a. And if x is approaches to a from left, you can say x is less than a. Now x is approaches to a from left, it symbolized like that x is tends to a minus. And the meaning of this is x is less than a. Okay, x is less than a means x is a quantity which is less than a, smaller than a. So you can write x is equal to a minus something positive number. And what is h? H is a very small quantity and which is positive, and x tends to a plus means x is approaches to a from right, and x tends to a plus means x is approaches to a from right means x is greater than a. That means x tends to a plus means x is greater than a, and you can write x is equal to a plus h. What is h? H is a small quantity, positive. Okay, x is tends to a plus means x is greater than a, and which can be written as x is equal to what? A plus h. What is h? H is a small quantity. Here x tends to a implies when you put x is equal to a here, a cancel, h is tends to 0. Similarly, when x tends to a implies h tends to 0. You do not think then a plus is a number. Number is here a plus means x is approaches to a from right. This means the symbol, the meaning of this symbol. Okay, you already got that if a function fx is defined, then when x tends to a, minus x is approaches to a from left at that time if fx is approaches to some real number, suppose L1, then this particular quantity expression is written in a mathematical form like that: x tends to a minus fx equal to what? L1. Then when x is approaches to a from left at that time fx is approaches to what? L. And this particular concept is called left hand limit. It is called what? Left hand limit. Similarly, when x is approaches to a plus implies fx is approaches to suppose L2, then this particular concept is symbolized as limit x tends to a plus fx is equal to what? L2. And this is called right hand limit. This is called what? Right hand limit. Now if L1 is finite and fixed, finite means, do you understand, like suppose 2, 3, 4, 5, these are finite quantity, and fixed means the limiting value L1 is always 1. Suppose limit x tends to fx is equal to suppose 2 or suppose 3 or suppose 4, then it cannot say fixed. Fixed means it is unique. So limit x tends to a minus fx is equal to 1. If L1 is finite and fixed, then you can say that this left hand limit exists. Left hand limit what? Exist. Similarly, if L2 is fixed and finite quantity, then you can say right hand limit also exist. Right hand limit also exist. And if left hand limit is equal to right hand limit, both are same also, that is L1 is equal to L2 is equal to suppose L, say, then we can say that limit x tends to a fx is equal to what? L. And we can say that original limit also exists. This limit exists when left hand limit exists, right hand limit exists, and both are what? Equal. Then we can say original limit exists. X tends to a means what? Either x tends to a minus or x tends to a plus. That means x is approaches to a from what? Left and from what? Right. Okay. So I hope that you understand what actually limit is. The basic idea I just discussed. Now I am coming with my definition about continuity. Directly go to enter the chapter topic. Okay. So before going to start the subject, I am going to draw few graph of the functions, and I want to explain you that what is the definition of a continuous function in a particular point in its domain. Okay. For example, suppose that I consider the function fx is equal to 1 when x less than equal than 0 and fx is equal to 2 when x is greater than 0. Okay. If you draw the graph, you will see very interesting. This is x is equal to 0. Okay. Yes, x-axis is representing what? Domain. Y-axis is representing what? Codomain, or you can say range. So when x is greater than 0 means suppose this is 2, this is suppose 1 on y-axis. When x is greater than 0 means all the real numbers, because this is from here you can see that domain of the function is the set of real number. X equal to 0, x less than 0, x greater than 0, all are included. Okay. So when x is greater than 0, you see just greater than 0. Okay, the value of x, value of y of fx is what? 2. Or you can take any x greater than 0. You can take 1, you can take 2, you can take 3, whatever be. For everywhere fx is what? 2. So if you draw the graph, you are getting this, and you see this particular line never connect y-axis, never connect what y-axis, because for x is equal to 0, the function is not defined here. So you can say this is the function, just it is not touch the y-axis. Now when x is less than 0, for all x less than 0, fx is what? 1. So if you draw the graph, you are getting like that. Okay, and when x is equal to 0, fx is also 1. So f0 equal to what? 1. So ultimately the line will touch the x-axis, y-axis. Okay, now finally this is the graph. Now if I start from here, from domain का यहाँ से left से शुरू करें, I am drawing the graph in this way and move in this direction, and you see there is a disconnection. I must lift the pen. मेरे को क्या है, पेन को लिफ्ट करना पड़ा, इधर शुरू करके इधर गए और हमें पेन को उठाना पड़ा और फिर वहाँ से शुरू करना पड़ा. That means here the function is discontinuous. At what point of the domain? At the point x is equal to 0. So from the graph it is clear that the function is discontinuous at the point x is equal to 0. Now use the concept of limit. Left hand limit. Limit x tends to 0 minus. It means left hand limit at x is equal to 0. When x tends to 0 minus means x is less than 0. X is what? X is less than 0. And when x less than 0, what is fx? 1. So you have a 1 put karo, limit of 1 is equal to what? 1. Similarly, what is right hand limit? Limit x tends to 0 plus fx. Limit x tends to 0 plus means x is greater than 0. X tends to 0 plus means x is greater than 0. When x is greater than 0, what is fx? Fx is equal to what? 2. So from here we can see that both the limiter exist but not equal. Left hand limit is not equal to what? Right hand limit. So if left hand limit, if you compare these two concepts, here from the graph the function is not continuous at x equal to 0, and from the mathematical concept you see, analytical concept you see, left hand limit is not equal to what? Right hand limit at x equal to 0. Okay, that means at a particular point, if left hand limit is not equal to right hand limit, you can conclude that the function is discontinuous at that point. Okay, now consider another graph. Consider another graph of a function. Another function I consider. Suppose fx is equal to what? 1 when x not equal to 0, and fx is equal to 2 when x is equal to 0. If you draw the graph, you see for x is equal to 0, the value of y means fx, value of x is what? 2. And x not equal to 0 means what? You can say x greater than 0 and x less than 0, both are included. Okay, that means for x is equal to, this is 1, for x greater than 0, for all greater than 0, your function is y is 1, 1, 1, 1, 1, okay, all are 1, okay, and you connect this point, you are getting this graph. Okay, and you see here x is not equal to 0. For x equal to 0, function is not defined here, and therefore you can come across and you cannot touch y-axis. So there is a gap. There is a what? Gap. Similarly, for x less than 0, the graph is in this way, and you cannot touch the y-axis because x is equal to 0. The value of the function is not defined here. So ultimately, what we get? If you start from here, you are coming here, and again you lift the pan, and again you start here. So here the function is discontinuous. And at what point? At x is equal to 0. At x is equal to 0. And if you use the again limit concept, you see limit x tends to 0 minus fx, left hand limit is equal to what? 1. When x less than 0, fx is 1. and limit x tends to 0 plus fx, right hand limit for x greater than 0 fx is also 1. So in both the cases, in this case what happened, left hand limit is equal to what? Right hand limit. So after getting left hand limit is equal to right hand limit, still the function is discontinuous. So this is not the condition, necessary condition or sufficient condition to become a function continuous at x equal to 0. पहले तो लेफ्ट हैंड लिमिट नॉट इक्वल टू राइट हैंड लिमिट था तो कंटिन्यूस नहीं हुआ. इधर इस एग्जांपल में देखो लेफ्ट हैंड लिमिट इज इक्वल टू राइट हैंड लिमिट होने के बावजूद फंक्शन फिर डिसकंटिन्यूस हो गया, तो ये कंटिन्यूस फंक्शन का डेफिनेशन नहीं हो सकता. So this is not the definition, this is not the condition for a function to be continuous at a particular point in a domain. Now in this graph you see, if I change something where x is equal to 0, if I write 1 here, what will happen? From the graph you see, when for all x greater than 0 fx is 1, for all x less than 0 fx is 1, and just the function is not connect y axis. When x is equal to 0, what will happen? Fx is also 1. Therefore 1 x equal to 0 के लिए क्या हो गया? 1 हो गया, और x greater than 0 के लिए 1 हो गया, x less than 0 के लिए 1 हो गया, ultimately connect हो गया. So you see, if you start from the graph, you start and throughout the domain what happened? You can draw the graph without lifting the pen. So the function is a continuous function. So the function is a continuous function. Okay. So if we add from here, what we conclude that here in this case left hand limit x tends to 0 minus fx is equal to limit x tends to 0 plus fx. Already we get these two values are equal. Now we make what? When x equal to 0, fx equal to 1. That means f0 equal to what? 1. Also we make what? f0 is defined, and which is equal to f0 is what? Defined, and which is equal to what? Also 1. So ultimately what again, if left hand limit is equal to right hand limit is equal to value of the function at that particular point, here particular point is what? 0, then we can conclude that the function is continuous. So ultimately what happened? F is continuous at x is equal to 0 when left hand limit is equal to right hand limit is equal to value of the function. Very important is that the left hand limit, right hand limit must exist, and also f0 must exist. If all three are exist and they are equal, you can conclude that the function is continuous at x equal to 0. Now suppose that x is equal to a is a particular point in the domain of the function. When the function is continuous, f is continuous at x is equal to what? A. You can write the definition like that. Left hand limit at the point A equal to right hand limit at the point A equal to what? Fa, provided all are exist. Provided what? All are exist. So this is the finally we get, this is the definition of a function. Definition of a function to be continuous at a particular point A if left hand limit is equal to right hand limit is equal to value of the function. If I start the topic and I just write a function is continuous in a particular point A if left hand limit is equal to right hand limit is equal to value of the function, then what happened? You cannot understand how it is. Why? This is the definition. So from the examples it is clear that if left hand limit is not equal to right hand limit, the function is not continuous at a particular point. Again, if left hand limit is equal to right hand limit, then again the function is not continuous at a particular point. So to a function to be continuous in a particular point, it must be left hand limit is equal to right hand limit is equal to value of the function at that particular point, provided all are exist. I mean it is defined, exist, it is exist, and it also exists. Okay, this is the definition of a function to be continuous at a particular point. Now from the limit concept you already know that if left hand limit is equal exists and right hand limit exists, then original limit exists. From here you can write this is equal to what? Limit x tends to a, fx is equal to what? Fa. So a function is continuous at a point in its domain if limit x tends to a, fx is equal to what? Value of the function. Now this is one type of definition of a function to be continuous at a point, and this is another type of definition of a function to be continuous at a point. When in the examination question asked, show that the function or examine that the function is continuous at a particular point. When particular point में आएगा तो आप क्या करेंगे? ये formula use करेंगे. And when you are going to show that a function is continuous at arbitrary point or a general point, then you use this formula. So there is a use of this formula you utilize in such a manner. For a particular point you have to use this formula, and for general point you have to use this formula. Both definition are same definition, but at the time of using these two definition in the problems, you have to use for particular point this formula, for general point this formula. So this is the definition of a function to be continuous at a particular point. So I hope that I make you understand particular concept and of continuity, and when a function is continuous at a particular point, and how you use this definition in a problem for a particular point or for general point. So thank you very much to listen my lecture, and if you go through this particular lecture, I hope your conception will be fully clear. So hope that you try your level best, and also you go to the text, read the textbook and relate my concept, then your conception will be 100% clear. So thank you very much. Thank you. I will next video I will come up with a few problems related to this topic, and then when I discuss this problem, your definition will be more and more clear. Thank you very much.